You are looking at video 29 of my invention. I got a lot of new upgrades in it. I put the coils in it. You can see these new coils that I have invented. It's made out of this nylon material, and it's much better than what I haven't wrapped the wire around it yet. I also have these new holders he has made. That way the magnets don't slip around and they come out. Before I had them like these, and that it's much improved. I've also put a bumper on here so when it comes down it doesn't slam into the magnet. That's very important that you want to do that. I've also put a heavier counterweight inside of here with this gear, which is a little bit more, it changes in that, and it seems like it runs pretty good right here. It doesn't take much power to turn this over and make these oscillate. I'm just barely turning this with my hand very easily. I also made this so it's adjustable down inside here so I can pull back instead of bolting up to the side like those. I improved that, and also extended, there's like a little, let me lift this up underneath here. You can see how the cores come down. They have like little chutes and stuff that keep it in location. So these are some of the improvements. I'm just going to fire this up and show you what I've got here. Like I said, this is video over Unity 29 video. This right here is just a regular battery charger, nothing fancy. I like it because it's got a nice big gauge here and you can kind of see what I'm doing. I'm going to start this out on the 6-volt thing. These are 12-volt motors, but I'm just going to put a little bit of energy into it just to show you what's going on here. Watch as I go. Okay, these things are oscillating. You can see it there. It's not anywhere near the top. It's oscillating there too. You can see it. That is just 12 volts. Right there, right on the 2. It's right here on 6. It's got 6 or 12. So I'm putting only 12 watts into this unit here, and it's oscillating at this rate. As you can see, now I'm going to speed this up, and I'm going to dump 24 watts into it. I'm going to hit it on the 12 watt to show you how much faster it is. How much faster it's oscillating? You're looking at about 3 watts at 12 amps. 12 watts at 3 amps. About 3. Look how much this thing's running here. Going much further. I got these bumpers, and it's sitting on these bumpers. Got a little thin piece of paper here. Sitting on the bumper right now. I can feel it with my fingers. Just a thin piece of paper. But I can feel when it's hitting. It's hitting right on that one. It's hitting on this one. Top is hitting on this one. Feel it. That way I don't slam it into it. Now, it's running a lot better than that, a lot smoother than that. As you can see, it has almost another inch of orbit height compared to this old model. I'm going to tear this back down and rebuild this whole thing. This is the commercial prototype. And you can see how much bigger it is than that unit. This is the concept prototype here. I got a lot more brass in it. You know, it's for show when you take it in to show backers and that. It's very impressive. Very high level of engineering and design. It'll run very easily. You just turn this here and these things turn. It doesn't take that much. The thing about this is what it is, it's going to be taking horsepower and changing it into electricity. It is not a perpetual motion machine. I explained that. Don't tell me about unplugging it. I'm showing the inputs and outputs on energy. A lot of people show stuff, they're not telling you what they're doing. They're not telling you, well, I'm putting this in or I'm taking this out. I'm telling you what I'm putting in and taking out. On the lower, it has like 2 frequencies levels. You notice the one, I'm only putting 12 watts into it. Then I bump it up to 36 watts and get it to run at the higher speeds in that. So that's what I'm trying to tell you in that. I'm not too concerned. I'm going to start to take this apart and I'm going to start to wrap this and cut these out, and then I'm going to wrap my magnet wire around them. I just got them in there, just got it to work in that. It doesn't seem to be using that much more amperage. It seems like it went up about 1 amp. If you take it to previous video, it took the drag inside of here is about another amp. It added on to it. So, and it's pretty much oscillating at the same pace. You know, I mean, I could change a little bit in the gears down inside here. I could maybe change one little tooth or something. One tooth makes a big difference down inside there. Another thing is, I'm going to have to try different thicknesses of magnet wire. You know, the thicker the wire, the more amps. The thinner the wire, the more voltage you're going to get. So that's what's going on now. Now, what I'm trying to tell you is this is a concept prototype. It's, you know, if you believe it or not, your first computer it started after World War II. In 1969, when they sent a man to the moon, you could go to your drugstore and pick up a calculator that's got more power than what they had when they sent people to the moon. That shows you how things have changed. The first car wasn't something that you had, you know, it was basically a box on wheels. And as it kept developing, it kept revolutionizing. They put transmissions in it, they put filters in it, they put all kinds of things into it until it's developed. This is in its infancy state here. This is a little bit, this other prototype is going to be a more advanced one. I'm going to go a little bit further out and see what it does. Also, what I want to say is the first prototypes and stuff that you see weren't always, you know, what you see today. You know, it takes many generations. This right here, you're looking at the 3rd generation of the concept prototype. It has other generations from before and that. I got pictures and stuff, but I'm not going to go back to that. Just go back to video 1 and you'll see the first concept level of it. This is on the 3rd generation. This one over here, I'm going to start the 2nd generation of it. I'm going to tear it all apart, redo it from what I learned from this prototype. I'm going to incorporate it into that prototype. I have learned a lot of things on how much energy you put in and how much energy you get out. So that's what I'm working with. And it takes a lot of time to work with that. I'm going to start wrapping the coils. I'm going to have meters on each coil showing what it does and that. The thing is, I'm dealing with efficiency. I'm trying to eliminate magnetic drag, which is Lenz's law. That's what this is all about. I'm not trying to create energy or anything like that. I changed my mind on it. You can tell the difference between a scam and these other ones. A lot of the stuff you're looking at is little, what you want to call, what do they call those things that you put on the desk and stuff? What do they call that stuff? Novelties. That's what I'm saying. More than like a novelty. You take a look at the stuff. It's not batteries charging back and forth. This is changing horsepower, which is this. I'm feeding electricity in. I'm showing how much power I got. I'm feeding into the system, and this is what I'm going to be collecting it. This could be, instead of this being an electric motor, this could be a windmill, or it could be like a waterfall, or it could be a gasoline motor, or it could be anything. But this is just showing something here. Forget about this. This could be something runs a candle burning a steam engine and running it. It could be anything. So don't worry about what this is. I'm trying to show you something. That's what you have to understand. If people don't just get the idea, well, unplug it. It's not about that. You have no clue to what I'm talking about. This is the only thing that's around that's going to be better than Tesla. Nobody has been able to compete with Tesla. Everything like they're in a car engine. There is no difference between a Ford, a Chevy, or a Dodge. The engines. They all have transmission, and they all have intake manifolds. They all have exhaust manifolds. They all have pistons. They all have valves that open and close with the springs. They got the cam. They got the flywheels. They got it all the same. There is no difference between those engines. Unless something's all electric or something, even if something's a hybrid. The motor itself, it's the same. There is no difference. They all got fuel injection. They all got ignition systems. They all got the spark plugs. They all got everything. You know, maybe Ford's got this Eagle Boost or whatever, and Dodge has got the this Hemi thing. Well, that's all it is just a high compression system. That's all it is. It's the same thing. There is no difference. But this is a major verification from what Tesla has. Basically, all you could do is take this. When you take an electric motor like this, all it does is rotate and it repels. A generator does the opposite of what an electric motor does. It attracts. It tries to stop itself. This is going to be reversing directions. When it comes up, it's going to be reversing directions from, then when it comes down, it's going to be pulling itself in. So it's not going to have that magnetic drag. That's what I'm trying to get for in a nutshell. So therefore, it could be something, maybe revolutionize that, where I'm not trying to put the oil companies out of business or anything. I'm just trying to get more efficient. We have destroyed 200 of our Appalachian mountains, which cannot be replaced. And we're doing a lot of different things in that. And I'm just trying to make things happen. Let me run this one more last time, and I'll let you see what it looks like when it's running. And then I'm going to let you go here, because I'm running out of time.